Good afternoon, everybody. Good morning.
Hello.
Hello.
Hey, Josh.
Hey, man, how's it going?
Yeah, I'm doing well. Thanks for asking.
Hello, everyone. Sorry, my other meeting ran a couple of minutes late. Hello. Okay, welcome to all of the humans and note takers. I'm going to let you all read the antitrust notice while I turn on a light. I will be right back. Please read that in your own time. Hey, welcome everyone. This is our technical steering committee meeting, in case you were wondering where you are. Let me put my camera back on. We have a fairly full agenda today. So we're going to try and get through the bulk of the meeting fairly quickly. You've seen the antitrust policy. If you have any questions about it, please check in with your legal counsel. First on the agenda is working group feedback, and we're going to hand over to Sandy. Scott will not be able to join us for today. He and his wife had a baby yesterday, so he is off for the next couple of weeks to spend some time with them. On the working group feedback side, as we discussed last week, we are going to close out both of the working groups, handing over the work that we had identified to the community, creating issues on GitHub. I've asked Sandy to just put together an introduction to show everybody just an outline of that work and where it can be found. And if anybody would like to participate, to contribute, to do any of that work, you're more than welcome to pick up an issue, check in with Sandy or I about what needs to be done if you are unsure, and let us know how it goes. Sandy, over to you. I'm going to stop sharing.
Thank you, Justice. Just going to share my screen. Let me know when you can see it.
There we go.
And
I can see the Miro board on deck.
oh, thanks. I was wondering what I was looking at. Right, so during our contribution guide working group meetings, we went through a process of putting together this mind map, and we came up with a number of ideas of what we thought would be useful in a contribution guide. Through the working group process, you'll notice that some of the items in this mind map are highlighted in green. Those are the ones that have been done. The ones in yellow are ones that are in progress. And for the rest, that is the gap that we have identified still needs to be filled by contributors to the guides. So what I have done is there's a project in the FRMS COE GitHub organization called the Contribution Guide Working Group. And in here, I've created issues that align back to the board around the gaps that we identified. So under done, you can see items that I mentioned and highlighted had been done, for example, licensing checks, things like the release management guide that Scott did. So those are the done items. So what we have under the planned needs delivery, these are pretty much ready for anyone to pick up. So, for example, this guide for anyone or for all, being a contributor onboarding checklist with a Mojo Loop example. This is just one example of an issue that we've created with a link to the Mojo Loop example. So yeah, so you'll see I've followed a pattern of saying who the guide would be for, which ties back to our mind map around the audience. So whether it's a tester or someone writing documentation, DevOps, developers, etc. So this is the list, and anyone's welcome to come pick up one of these items, and yeah, we can chat about it and they can work on it. Justice, back to you.
Thank you very much. And just to double check, those are all in the docs repository, right? So
Yes, yes.
perfect. So pick up an item, do some work, and we'd really appreciate it. Right, let me take the share back.
Just a quick question, if I may. I see there's another project, well, that project that Sandy just demoed that was created in the FRMS COE organization and not the Tazama LF organization. Is there a reason why we keep the projects in that repo or that org?
Sunk cost fallacy. That's where we start.
Historically. Sorry,
And
Justice, go
at
ahead.
the moment, yeah, we keep on adding more project work. So we don't really have a convenient opportunity to migrate the entire project space across. So unfortunately, and we do still have tickets that exist inside the FRMS COE organization, especially when we are doing work on the rule processors. And it does seem to be easier to link in the private repository issues into the FRMS COE projects than trying to link them into public projects that exist in the Tazama LF. So it's not ideal. I don't think GitHub is specifically designed to handle a blend of public and private repositories seamlessly, unless you're a commercial organization.
Yeah, the reason why I'm asking is because the docs repo is in the Tazama LF, and now the issues is in the other project, so it's going to be confusing the other way around.
The issues are still in the docs repository. Sandy is just tracking the project on the FRMS COE part, so the issues are still created in docs.
Okay, cool.
Yeah, we just link them into that project for transparency, and so that Sandy can see what people are doing and where the work is going. Thank you very much. Next on the agenda, going back to here. We did issue last week, we published the dynamic data ingestion sort of specification. I don't know if in the past week, if anybody had an opportunity to look at it, if there was any discussion or comments or feedback that anybody wanted to bring to the TSC, or are we in principle happy to proceed with that design pending at some point, as Foley pointed out last week, an understanding of exactly how it is going to work. And that we can set up for a future TSC as well, just to get our system integrator partner, Paces, to come and do a demo for us about the technology that they are proposing to implement to make that work. But I just wanted to use this as an opportunity to quickly check in if it was worth us having a discussion about it today. if anybody had any comments or feedback on it. Excellent. Winning. Okay. If anybody does have any comments, you are free to make comments in the document. But as I said, we will come back and do a demo of the proof of concept to our technical steering committee meeting at a future session as well. Right. For today, what we are going to be talking about is multi-tenancy. Multi-tenancy is also a functionality or more of a non-functional requirement that has been requested for delivery for Camisa. Essentially, what multi-tenancy means is the ability for multiple tenants to interact with a single instance of Tazama without tripping over each other and inadvertently accessing data that they don't have any rights or privileges to access. So we are talking about segregating functionality all the way down to the data layer to make sure that the data remains secure. Greg?
Oh, no, I was taking a drink, sorry.
Okay. Best to stay hydrated.
Yeah.
Multi-tenancy has an impact across our wider ecosystem, and in particular on the Tazama transaction monitoring side, as it is the core component of our entire ecosystem. We are leading with a multi-tenancy implementation in that area, which means we also need to review that implementation with our technical steering committee meeting to make sure that everybody is on board with the proposed changes, and also give everybody an opportunity to challenge any of the decisions that we are making around the requirements and also subsequently the implementation. So this is effectively an enhancement on existing functionality. Once we have established the pattern and the functionality for multi-tenancy inside the core system here inside the Tazama transaction monitoring system, we will then be using that as the foundation for multi-tenancy in all of these other components as well. So the similar pattern will then be rolled out across the rest of the ecosystem. From an overall architecture perspective, as you all know, inside the transaction monitoring system, there are a number of different steps or components, and I did not actually create that as a slide, which in retrospect, for context, is an oversight. So I am going to inflict on you one of these ones. Right, so you would all, I hope, be familiar with this particular picture. So this is the internal flow. We ingest transactions into the transaction monitoring service API. Inside the event director, we route those transactions based on the transaction type so that the specific rules and typologies that applies to a particular transaction can be invoked. And we then call all the rule processors, which evaluate a specific behavior related to that transaction and its participants. Those behaviors are summarized in the typology processor into specific fraud and money laundering scenarios. And ultimately, at the end of the day, there is a final result that is calculated as a report, and that report is published to the internal Tazama database, but also if there is a breach of any of these thresholds, that report is communicated onwards to a case management system. So when we are talking about multi-tenancy functionality, we are proposing to update all of these components that interact with the database and also does the evaluation for a particular transaction. Our assumption here is that if a particular tenant sends through a transaction to be evaluated, that transaction evaluation happens in isolation without the knowledge of any of the other participants in the system, and also without being able to use any other participants' data in the system. So it is almost as if that tenant is accessing their own instance of Tazama while sharing an instance of Tazama with a number of other tenants. So what that means for us is if we start at the front of our process in the transaction monitoring service API, one of the key components that we implemented in Tazama 2.1.0 was the ability to authenticate our transaction submission. The system that is sending us a transaction to evaluate has to authenticate themselves using Keycloak, which is our identity and access management system that we implemented for Tazama. That then means that if we have multiple tenants interacting with the system at the same time, we now need to be able to create unique tenant profiles for each of those tenants. Now, if we are looking at how that would typically work inside Keycloak, Keycloak uses the concept of a realm. And at the moment for Tazama, we had set up a general Tazama realm. And then inside the Tazama realm, you can set up your users. Now, if we want to be able to further segregate that by tenant, we almost have two different approaches that we can follow. The first one is option one, where we can say every tenant now has their own realm, which gives us complete separation down to the level of users and the tenants themselves. The pros here is very strong isolation. It is also tenant-specific login flows for everyone, the roles and users, everything inside these spaces is unique and isolated to that particular tenant, and it is a complete separation of that tenant inside Keycloak. The cons here, it is actually quite hard to deal at scale, especially if a large number of tenants that you want to connect to your system, because you are going to have a realm for each one of those tenants in the system. The alternative option here is to create client tenants underneath the Tazama realm that already exists, which is a slightly simpler way of implementing the system. We do not typically anticipate that the system will be used by so many tenants that it would become unmanageable. So not sure whether or not this con would actually matter in our environment, but it does seem that this is somewhat simpler because it leverages a pattern that we already have in place. So we already have a single realm. We already create user profiles underneath that realm. So we are basically just extending that with a particular client tenant architecture. What I'm not too sure of here, and I think Foley, if you do know, I'd really appreciate your input, but whether or not the users that you would have associated with a particular client would be subordinated to that client as well, or whether or not this client is effectively just a user itself. And if I have a number of other users related to a particular tenant, if they would effectively end up blended on the same level.
I remember correctly,
yeah.
your user is part of a client. So your user is registered to a client. So this looks fine.
Okay, perfect. Because the other thing to also remember is we are proposing to use Keycloak here as the identity and access management system for the entire ecosystem. So we would want to be able to set up the users that would interact with the rules and typology management area, the configuration module, the rule builder module. Also here in the business intelligence area, any authentication has to happen through Keycloak here as well. So you will have a wide variety of users and roles that need to be set up in the system. And we don't necessarily want to mix people up here. We still want to be able to segregate even those roles and users by tenant. Greg, you have a question? You are on mute. I did see your hand up.
Yeah, I was on mute. Now I've got a phone call. Just a second. Let me hang up on that. Freaking salespeople. Anyway, so originally, I assume you know DSI as PCI DSS. And what did you do for credit cards? Yeah. So originally, they only allowed you to do option one. Everything had to have its own domain. It couldn't touch. It was like having food on a plate. You couldn't intermingle data at all. And that was because they had to assess how you could do option two correctly. Eventually, they got to the point where they were comfortable and they allowed option two. What about the bank privacy statements? Because this would not work. This blending of clients would not work in the Philippines. I don't think it should, but I don't think it will.
I'm happy to take input on that. Ultimately, if that doesn't work, then you are basically talking about segregating the system all the way down to the infrastructure, which was not how far we were proposing to go.
Not scale well that way. I agree with you on all that. Yeah.
And if we were doing that, we might as well just create a separate instance of the system for each of those tenants rather than trying to put them onto the same infrastructure. But then I expect that those people would lose the benefits of better economies of scale. And the sharing of infrastructure would then not be a viable sort of a business case lever in that environment. We are specifically proposing to take segregation down to the data level without having to separate it at the infrastructure level so that we can leave economies of scale on the table. If it's off the table, then just install your own instance of Tazama is basically my view. And I'm happy to put that out there to our community to also say, how do you feel about that? Do we have to find a solution where we are actually taking multi-tenancy down to the infrastructure level, or is a separate instance of Tazama a acceptable alternative?
Yeah, they were happy with the VMs in option one, but they weren't happy with going to the database level or using like a tenant ID or something like that at first. But then with option two, there you would have a tenant ID in there, but the data is typically mixed within the database. But in theory, the LLC their own stuff, and that's how you get the scaling, right? Just from my perspective, it's just something we had to watch.
Yeah.
There are going to be some accounts that or some countries that are very, very specific about that.
And my response is, if it does become a firm constraint for an implementation, just implement your own instance of Tazama instead.
Yeah. All right.
Roland? Roland, I see you.
Sorry about that. I was connected to the wrong microphone. You guys can hear me now?
Yes, I can hear you.
All right. Yeah, I was just saying that from the Philippines front, there's no, option two definitely works for the Philippines. I mean, it's fine if we can do isolation at a tenant ID level and having logical isolation. So that's not too much of an issue. The bigger problem in the Philippines, it's beyond which I don't think is part of the multi-tenant stream, but it's more the fact that you have to depersonalize any personal identifiable information. So basically hashed values or pseudonymize or whatever it may be of personal identifiable information. And then the other key thing is that we can go with option two. It's just that as long as the thing is robust. In other words, it's we have to make sure that the client tenant is that is authenticated at every single step of the flow, as well as
Yes.
for obvious reasons it can never be leaked between the different people. And then the other thing I can also suggest here, and it's basically because on our product we work with in Cybrin, and it's lessons learned we've had, because we've also had to do multi-tenant environments for some of our different enterprise clients. And sometimes you have to actually work with both options, and I'm talking more from the data layer perspective, is that you may have a multi-tenant environment and they're all sitting on a shared, let's say, for example, at this stage, a shared Arango store.
Mm.
They have a larger enterprise or a larger organization, or larger tenant, sorry, let me put it that way, that may have quite significant volumes, and you actually need to shard it that you actually give them a dedicated Arango backend. That makes sense. Although they are still very much sharing the infrastructure. It's just that there is some rules that you turn around and say, okay, cool. If you've got this tenant ID, I want to map this tenant ID to this Arango instance.
Okay. I need to think about how that would actually work, because obviously our Arango DB access is driven out of environment variables and configuration documents that are set at deploy time. So we don't currently have another mechanism inside all of the processors to differentiate the ArangoDB destination. That would be quite a significant overhaul, I think, of our current processor pattern. But I take your point. I mean, it might actually be better, not just for multi-tenancy, but also just for performance preservation. So some people it may be better to put them in their own database. I almost want to say is if you have a tenant of that size, you're probably almost better creating them their own instance anyway, as a workaround.
Just to remember, yeah, Justice, remember you're also looking at from an aspect not only be a tenant of that size. That was our original thing, but where we've actually had the experience on it is that as you increase in volume of tenants, it sometimes does make it feasible that you start physically separating tenants into separate databases, and that's where it actually also happens. So,
Right.
like in the Philippines, if they did grow to like a huge scales and you hit the rural banks, you potentially have 400 tenants there. Then let's say if you want to keep that same layer and you're now busy onboarding other entities like co-op banks, if you try to extend this thing as a solution within Kenya and you want to do it as a shared service for SACCOs, there could be significant volume of tenants. And it's just to allow you that you still have that capability to scale across multiple data stores.
Fair enough. I mean, it might actually be as simple as saying if you've got 400 tenants on the thing, you might want 200 tenants to go this way and 200 tenants to go the other way. So you do want some physical separation in the infrastructure as an option. I'll take that away and take that into consideration. I might want to propose that we almost put that forward as a phase 2 design, so that we do the initial phase for sort of unified infrastructure, and then do a second phase to extend that to sort of separated infrastructure as well, especially around some of the components that would rely on better scaling. I think the database is probably a good example. The rule processors and everything else might still be fine. We'll just have to find a way to sort of redirect the destination of the query to the appropriate infrastructure based on the tenant ID. So some sort of intermediate translation layer of some kind would then be useful. But thank you. That's actually, that's a good observation. It's a good point.
Then, sorry, one last thing. And I don't think you'll be able to solve it with Arango. And I don't know if it's a hard requirement now, but it might be a requirement down the line for other clients. Is that when considering your different data providers, that some data providers do provide a form of a row level security.
Yeah.
And where that helps with that row level security is that it's natively supported by the database. That's and where that's key is that as a support engineer, like I say, you're as Cyber as a systems integrator. They have right now, if you were to work on this approach of option 2, you would have visibility of the data of absolutely every single tenant. And you may have a position where you're going to want to have it that you have a form of row level security and different people, different SIs based on different tenants, or there could be groups of different SIs that can only access certain, that only have the right to access some of the data. Do you follow where I'm coming from?
Yes, and I think what we are proposing initially is a sort of a logical security layer. So the top level code handles access to the right data. But it would be far better if that level of security is actually handled in the database itself directly, so that if an administrator needs to access the data for whatever reason, that administrator should only have access to the portion of the data that they have the rights to see. And that right should be assigned out of Keycloak as well. So again, it's a very good point, and also something that I will add to our list of requirements so that we can consider that. As far as ArangoDB is concerned, maybe just as a heads up to everybody for FYI, we are currently commissioning a POC just to investigate an alternative database provider for the core system as well. We are currently evaluating PostgreSQL, and we'll be able to give the community feedback on that in about, I don't know, 3 or 4 weeks or so. Okay, thank you very much. Thanks for the feedback, everyone. And then moving on, so what we would do here is inside Keycloak, each one of these tenants would have a tenant ID custom claim that would then contain their particular tenant identifier. So whenever they are interacting with the Tazama system, they would be submitting that tenant identifier so that the Tazama system can then keep track of the tenant, can then tag transactions with the tenant identifier, can do all of the routing, the configuration management, everything downstream from your system access should be ring-fenced by your tenant ID. So the tenant ID will be set up here in Keycloak, and then that tenant ID will effectively be your passport to system functions going forward. So for example, how that would typically work here is on the ingestion side in the TMS API. You would get your token through our authentication service API. That token would be derived from Keycloak. You would submit your user credentials here. Keycloak generates a Keycloak JWT token, which then in our authentication service API is converted into a Tazama JWT token. That JWT token will contain a claim called a tenant ID, and that will then contain the tenant ID that you have been allocated for that user profile or that system profile inside Keycloak. When you then submit a transaction into the Transaction Monitoring Service API, you will use that JWT token as the method authentication, and you will send your transaction through to the system. The TMS API then does its normal authentication to make sure that you have the appropriate access that you do. So there are other claims in this token that gives you access to certain services on the API. But there will be an additional claim there that says there's a tenant ID inside that array, and that tenant ID will then be used to tag the transaction. So in our data preparation step inside the transaction monitoring service, we will be embellishing the payload with a additional tenant ID tag. And that tenant ID tag will then define which tenant has access and rights to that particular transaction in the database. And that will then be used going forward to filter queries and interaction with the database by tenant ID so that you are only able to access the data that you have the privileges to access. And then in the database, I think as Roland already alluded to, your transactions will be mixed in with everybody else's, but the transactions will be tagged by your particular tenant ID so that queries are filtered by the tenant ID. I want to quickly pause here because this is essentially the core mechanic in the data architecture going forward. So does this, one, make sense? And two, is this something that everybody is comfortable with? And three is, can we go ahead with this pattern?
Sorry, I'm guessing this is the same pattern that you also use with configuring rules.
Yes, we're going to get to that. So there's once we've agreed on this, then I can tell you what all of the other magical things that we're going to be doing. But yes, there's a lot of downstream work that also needs to be performed, especially if tenants want their own rule space. They want their own configuration space and configuration sort of schema. Everything downstream needs to be separatable by tenant ID.
Okay. The reason I'm bringing that up is, again, it's a little bit of lessons learned that we've had on our own product, is that when you're doing the configuration side of things, there are times where you're going to have like you could potentially, especially on the rules configurations, that you could have a need to actually override your tenant. So I see you put in a tenant ID as your JWT token, but there may also be a need where you are going to have to say, I want to impersonate my user now using this tenant because I've actually got access to multiple tenants as this user.
Mm.
The classic example there is that you could be a provider that that is responsible for doing the rules building for multiple institutions. And then they need to have that ability to say, cool, I'm coming in, I'm hitting my configuration portal, and I say, okay, open up the rule, and I want to now impersonate as this tenant.
We did kind of think about that, but our ham-fisted approach to that is that you will have separate user IDs, and those user IDs will be within a specific tenant domain. So if you need to work on this tenant's configuration, you need to log in as a user from that tenant. There are probably more elegant ways of doing that. We did not go that far in our design yet. I think we would probably want to consider sort of the combination of tenants under some sort of administrative profile at in the future. But yes, again, that is something that would be useful. So thank you again. I mean, it's actually really great to have somebody on board who's done this before so that we can learn from your experiences. Anybody else? Thank you, Roland. No allergic reactions? No alarm bells? The biggest risk that we have to point out with this particular design is anybody who has access to the database has access to everybody's data, which is not ideal. That also raises Roland's earlier point that the data itself at the database layer should actually be protected by keycloak based, tenant ID based access anyway. So even if you were to be able to access the data, there should be no way that you can see anybody's data except your own. And we will definitely take that requirement into consideration. See if there is a way that we can do it in ArangoDB if we're going to be sticking with ArangoDB, or in Postgres if we do decide to pivot to an alternative database. Right. Everybody comfortable? I kind of feel like I need a show of hands here because this is such an important component of the architecture going forward. Is there anybody who has an objection? Is there anybody who does not have an objection? Please also feel free to object later. Greg? You put up your hand to say yes. Okay, cool. I think so far the ayes have it. If you do think about something later that we need to consider, please do let me know. We're also very happy to have this conversation here with our community as often as we need to ultimately sign this off, if there is a disagreement or a challenge to the approach. Right, so once the message itself has been ingested, it's been put into the database, it has been tagged by the specific tenant, so everybody knows whose transaction that is. You then want to be able to route that transaction through to the rules and the typologies. Now, at this point, at the moment, what we have is a single network map that handles all of the routing. So the easiest way to do this would be to say we will just add the tenant ID at the top of that branch so that every tenant in the system has its own section of the network map, right? So they will have their own transactions that they want to evaluate in the system. They will have their own typologies. They will have their own rules that they are running. They can still reuse rules that are run by somebody else, but they will have their own network map that defines the routing of the transaction through the system. The downside of this particular design is that if any tenant wants a change to the network map, you will be deploying a new network map for the entire system, which means every tenant, which may be a bit of a logistical challenge. So this is a very simple change. We are just changing the event director and slipping this tenant ID in at the top of the network map and then changing the event director code. From an implementation perspective, this is fairly simple. From a management perspective, you now have the additional challenge of managing a single artifact amongst a number of different stakeholders, which may be less desirable. The alternative here is to basically create a network map for each of the different tenants. So each tenant has its own network map. What that would mean in system terms is each of these network maps have to be cached separately for performance purposes. So we no longer have a single network map that we cache for the entire system. We now have multiple simultaneous active network maps that are cached inside the event director's node cache, and they are individually keyed by the tenant ID. Right. So throwing this out there, Any other pros and cons or specific preferences from the community about which of these two options would be preferred? And then I'll tell you which one I prefer. Anybody brave enough? Okay, spoiler. I like this one better. It does make for more complex development. So updating the system is a little bit more complex. The node cache itself, I do not expect will be burdened with a whole lot of additional data. So from a bandwidth perspective, I don't expect that the performance to degrade. But in the long run, it will be much easier to manage a single tenant's network map in isolation. Right, so they have their own network map that runs inside the event director. They can update their own network map without impacting anybody else's network map or anybody else's workflow and performance and behaviors. So this to me feels like a slightly cleaner approach. Would anybody like to differ? Would anybody like to agree? Thank you, Foley. And thanks, Roland. Okay, so this is the option then. We're going to be managing these at the same time. One other thing that we do need to consider, and we are going to come back to a future technical steering committee meeting with this requirement as well, is at the moment we don't actually have a mechanism to kick off a new network map or any configuration really without restarting these processors. So we do want to create a mechanism at some point where you can give processors in our end-to-end flow an operational instruction during runtime to, for example, read the network map from the database from scratch. So that's something that will be helpful here, because at the moment, if tenant A updates their network map, we need to reboot the event director for the network map to take effect. And if we reboot the event director, it's going to take down the workflow for tenant N. So we want to be able to avoid that. So there's a problem that we are going to be present to the TAC at some point in the future, and then we'd appreciate your input in how do we address that. But for the moment, I think this pattern is fine. Thank you very much. Option 2 it is. Right, rules development and deployment. So at the moment, it is probably fine for the system to have universal rule processors that will apply to every tenant in the system. Rule processors in particular, we consider a slow changing dimension in the system anyway. But it is possible that somebody might want to build their own version of a particular rule processor. So at the moment, the way that the network maps and everything is structured, the way that you could target a specific configuration version and a configuration through its identifier in the network map, this is functionality that is already available. There's no difference between creating a new rule processor for a tenant or just creating a new rule processor for yourself. In the long run, the principle will still be the same. You can deploy that additional rule processor as a module of code to your environment. It will have its own address where you can reach it through NATs. So as long as it has a unique identifier, you'll be able to address it uniquely. And that will be defined in your network map. And in your own custom rule configuration, you can then also apply to that particular rule processor, and that is also defined in the network map. So this is not functionality that we necessarily think needs to change. The big difference here is for us to be able to retrieve the entity-specific or the tenant-specific configurations, we are going to have a similar pattern that we had for the network map itself, where we have to cache all of these different rule configuration versions inside the rule processor's node cache simultaneously, and then use the tenant ID from the payload to be able to pick up which configuration we want to read from the node cache, and then also the configurations themselves will need a extra identifier that references the tenant ID to say that this rule configuration was created for and by this particular tenant. It is used by that tenant and that tenant alone. So there is additional sort of identification required for all of these artifacts to identify the specific tenant. Right. Everybody comfortable with this? We don't really see this as a major change. I think this is fairly straightforward, but does this make sense to everyone? Cool. Thank you very much, Foley. Thanks, Greg. That then moves on to how the rule processor itself behaves. So at the moment, the rule processor effectively has a query that it runs to retrieve data from transaction history. All of the queries in the system will have to be added or have to have an additional filter that can ring fence the data scope of the query to the tenant ID. So the tenant ID that is now supplied as part of the payload will be added to a filter inside the query that will then only extract data from the database that belongs to that particular tenant. A tenant cannot see any other tenant's data. They'll only be able to see their own transaction history in the database. The risk here is that somebody could, in theory, create a rule processor where they don't have the filter built into the rule processor, and then they will be able to see all of the data in the database. This feels like something that could be managed through an operational control, but an operational control here for me is still a risk. So this is something that we do want to consider both during our rules development process, the rules review process, but ultimately this is something that has to be closely managed by the operator of the system to ensure that there is no tenant that has created a rule that basically mines the database for other tenants' information. This is a risk, and this is something that we have to put some effort into mitigating. And again, if anybody has any ideas, that would be great. Roland.
Yeah, just what would be good is that between your data layer and the rule processor or whichever service is whether or not you put in a form of a gateway or something like that that just validates
Yes.
put in some form of validation to make sure is there a tenant ID is the tenant ID part of that query, and if it's not, then you throw back the exception. There's that, or else the other approach, which I think is a bit too invasive, and it could be would be a greater performance impact, is that the tenant ID doesn't get added at the rule level. The tenant ID is added at this gateway that sits just before the database provider.
So in theory, you could add like automatically on behalf of the user a tenant-based filter over here, but it will depend on the kind of query. I think, but that is an excellent suggestion. I think to be able to validate this perhaps in the database manager. We have a database manager function sitting in the library that effectively handles communication with the database. So at least to be able to validate this function that it contains one is a bare minimum. But to make sure that it actually is something that is validated at a functional level, to make sure that it is including one that actually works, we'll have to look at how we can do that. But that's an excellent suggestion. Thank you very much, Roland. Any other sort of additional ideas or how we can make sure that we can't have rogue rules that reads the whole database? Either by accident or design.
The other one is that the other obvious one, and I'm sure most people on the call are aware of it, is if the database supports row level security, then at least like at that level, you're guaranteed that because now it's actually locked down from a permissions perspective.
Yeah.
So that would be the first best bet. I don't know if Arango does support it, but I do know that, like for example, Postgres or I think MySQL, those databases do support it.
So in theory, some of the feedback that we've had from Camiso's security team is that we should actually give user specific authentication at the data level. So in theory, if you are a user from tenant A, then the Arango DB itself should have a user profile set up for tenant A, and then there should be some sort of correlation between the query that you are making as being from tenant A to the data that you are allowed to see in the database. What I'm not sure about is whether or not Arango DB has a correlation between the user profile and the data itself. Like, is there a additional sort of a security tag attached at the transaction level that links that transaction to the Arango DB user profile? And that's something that we can also explore. So if it is possible then to create a user ID, tenant ID in Keycloak, a associated user ID, tenant ID in Arango DB, and then tag the data inside Arango DB by that tenant ID, then that would almost solve this problem by itself. You then don't even need the filter here.
Yeah.
Okay.
You're saying that just as that's just a layer, is that because that's basically that is basically row level security, and it's where it would be done is that it would generally you would tag it based on the connection string. So it is a thing you're going to have to look at the design of trying to find a way to do a dynamic connection string to get to that level that per tenant that when there's going to be a process on your startup that you're going to have to go along and say, cool, I've got my master connection string to access the database that allows me to go and fetch a connection string for my tenant.
Yeah. Okay.
You got me there.
I'll definitely look for that. I think that would be really useful. If it's okay, if I could check in with you around some of the finer points around technically how to talk the language here, I'd be very happy to talk to you later. Okay, thank you very much. Thanks again, Roland. So what would then happen is inside the rule processor will retrieve the tenant-specific configuration out of the node cache. It would get the tenant ID out of the payload, and it would then run the query over the data to retrieve the tenant-specific data, and then ultimately would deliver a rule result that is entirely ring-fenced and focused on that specific tenant's data and that data, the customer's behaviors. Moving on then, from the typology processor perspective, the pattern is exactly the same. So the only difference here is there is only a single typology processor in the system. At the moment in Tazama's architecture, we do accommodate multiple typology processors, but at the moment we have had no need to actually implement any of that yet. So we are proposing to still just maintain our single typology processor in the system, in the design. But in the configuration layer, you would then also have that additional tenant ID so that you could explicitly identify the configurations for the typologies that belong to a specific tenant. So this is very similar to the pattern for the configurations for the rule processors. Then the only final piece here is system egress. Right. So at the moment, what is happening in the system is we rely on a number of point-to-point relay services, right? And when we say point-to-point, they are very dumb routers. They basically accept information with the left hand, and then they hand over information to somebody else with the right hand. There's no third hand here. So essentially what would then happen is if we were in a multi-tenancy environment and we needed to be able to relay the results of an evaluation to a tenant-specific destination, then we need to look at how this pattern is implemented. We don't necessarily want to make the relay services themselves smarter, and upfront we don't necessarily have to. So in the system, we can implement a pattern that just basically says, we are routing from each of these components to a tenant-specific NATS endpoint, and NATS is our pub sub interface in the system. And then beyond that, that NATS endpoint would have its own relay service that it can then use to hand over the data to a tenant-specific destination. So interdiction service for tenant 1 would have a relay service for tenant 1, and it can hand over to client system tenant 1 through NATS. Or tenant N could hand over through a relay service that should have said N, and that would go to a client system via REST API or Kafka or RabbitMQ, which is all of the different transport mechanisms that we have built so far. On the case management side, we are not sure. You may have another case management system, so a specific tenant may actually also want information to be sent to their own case management system rather than the tenant operator or the Tazama operator's case management system. This for me feels optional still at this point, but to extend the pattern to be able to send to multiple case management systems doesn't seem overly complex anyway, so we might as well just do it just in case somebody needs it. It's not a big change. But what I do want to check in with the audience is this fine, or do we actually want the relay service to be able to distribute to multiple destinations, which I'm personally not a big fan of. I prefer the relay service to continue to be a dumb point-to-point terminal, not a smart router. Input and feedback from the audience. Anybody? Polly and Roland. Polly first.
Thank you. So the problem I foresee with saying we should have a relay service per tenant is that you're going to have multiple applications that's up and running. Whereas up to this point, we still only had one theoretical application running, and it would load the different config. But by having multiple relay services running, you're going to have separate applications running per tenant, which sounds very heavy on the hardware side.
When you say applications, what do you mean applications?
Well, the relay service, as per this picture, is a application, right?
Sure, it's a module of code. So yes, it runs in its own pod.
Yes. So
and that was a deliberate decision at the time, just for everybody else's information as well, because these can scale independently, right? So you can ramp up or ramp down the scaling requirement of a particular relay service. So if this is a high volume tenant, this relay service can have more resources available than this client tenant because it only gets a few transactions per second, for example. But yes, you are correct. These will become separate, discrete software components. It's not a unified component.
Yeah.
Roland?
Yeah, just a bit on the other end is that, sorry, I'm not looking at the relay service into NATS. I'll defer to Freddie because he's got much more experience than I do on that. But it's more on hitting a relay service and going via REST to a CMS. And if we, I don't know if you could be open to when the client, basically when the client sends through their transaction, that part of the payload of that transaction is a callback URL. So what helps quite nicely with that is that there's no centralized configuration dependency for the customer, because I'm also thinking of just a customer that's really working on complete shared service, and they don't really want to mess around with configuring or anything like that. And it's a tenant that comes in, sends it, and they would want to put a callback URL, and it could also be different callback URLs they want to use based on the different transaction types they're making use of. And then the other thing is a callback URL to also make sure that they are as compliant as possible with disaster recovery. So they have, if they use that callback URL, it really keeps them disconnected, if you get what I mean. It's you provide a callback URL. If they do invoke disaster recovery, they don't have to change anything on the on this Tazama stack. They just modify their callback URL to inside of the transaction request to point to the DR site.
Can I ask, because that is almost a alternative to the relay service distribution pattern entirely. I've always liked the idea of a callback pattern, but not really been sure how to go about implementing one. Would you be open to maybe just submitting a draft specification or a proposal for how that might work in the existing system, that we can then review at the TSC?
Yeah, sure, no problem.
Thanks, I appreciate that, because I've always wanted to implement one. I'm a big fan of the idea because it will also make a lot of other things simpler for us. As you know, the system is not a synchronous call. It is an asynchronous call. So it's basically a fire and forget of your evaluation. But we are struggling with the mechanism to bring the message back or the outcome back to the client system. So a callback pattern would be a great approach. And if you would be willing to do a draft proposal for us or a spec, that would be awesome. And that would be another integration mechanism that we can then add to our menu. Okay, Folly. I want to get back to just the point you raised, and I know that we are a little bit over time. Thankfully, everybody here is a South African, or almost everybody, which means that, you know, hopefully I'm not cutting into too much of your dinner time right now. Would it be feasible to see how this goes? Because ultimately, I think if we wanted to combine or to create an alternative relay service that is actually multi-destination capable, that is something that we can do as a future phase if we then decide that this point-to-point relay service pattern is not feasible for every implementation. Would that work as an interim solution?
Well, in theory, yes, it would work as an interim solution, but I'm just wondering why we didn't choose to go the same configuration route we did with all the other processes. We just manage it by config, and the relay service can then decide. So if I'm a REST relay service, then I can read the config and figure out where to send this thing to.
Well, you're going to do that anyway, right? Because every relay service will monitor its own NATS endpoint, which is what they currently do, right? At the moment, there's just a single NATS endpoint for them to monitor. So in the future, every relay service will still only have its own specific NATS endpoint to monitor. The work happens in these components where they need to know whether they are sending their output to a tenant-specific NATS subject, or whether or not they are sending their output to a generic NATS subject, right? So the configuration will happen here in the typology processor. The relay service itself for a particular tenant will be configured exactly the same way as it is now for a single tenant. You would tell it where to get its information from, and you will tell it where to send its information to. And that's still going to be configuration.
Yeah, but you will have to have multiple apps for a relay service per tenant.
Yes,
and
you will have a relay service per tenant. You are correct.
So in a low-scale application with many tenants, you'll have many apps, relay service apps running. But yeah, in the
Yes.
initial idea can work. Yes, it's not that this design can't work. It's just it's
It
quite
may be
hard to
cumbersome, right? So if you have many tenants, sure, it might actually be cumbersome to run all of these individual relay services. What I'd like to understand is there a way for us to quantify the cost? Because I think ultimately it comes down to a cost effort, right? Or a cost issue. Is there a significant cost to running one of these relay services that is capable of delivering throughput at a rate of, let's say, 20% max of the system's actual throughput, right? I don't know. I don't know how to quantify the cost of that because these are not big components. The biggest part of this component is probably the Node.js that you need to make it run.
Yeah, just as the other thing is that it's not just the cost, it's also just I would say the operational thing is making sure that all those relay services are running on the same version. Yeah, it seems like a clunky design.
And further than that, it's also you've got limitations on the technology. For example, Kubernetes only allows 110 pods per node, and if you've got many tenants, then you have to spin up additional nodes, which is more hardware just to be able to run more relay services.
Is the suggestion for us to then create a sort of a multi-output relay service?
No, the relay service by design says I'm a REST relay service, right? And what I'm saying is, if we have 10 tenants that want a REST relay service, we just have 10 configurations, and then there's just one REST relay service that's able to interpret the configuration based on tenant ID. So similar to how all the other processes work, you just add the tenant to the relay services config.
We are over time. I'm going to park
Yeah.
this one. But let's come back and then just talk about the relay service itself. I take your point. I understand now fully what you mean with the configuration. It doesn't feel like something that I would want to do at deploy time, but maybe something that we consider for runtime. But let's come back and let's review that. But in general, thank you very much, everybody, for your feedback. I think overall, I'm comfortable that we have ratified the design. If anybody has any objections or thoughts later, please do let me know via Slack or email. Cool. Thanks, everyone. Appreciate your participation and your engagement.
Thanks, Justice.
Thanks, Justice. Thanks, everyone. Cheers.
Thanks all. Enjoy the evening. Bye-bye.